Hi guys, welcome to the exam revision post for COSC 33530. So the information that you've got in this post is relevant to both exams, so for both levels. And I'm just going to quickly run through what you can expect the exam to cover and some hints for each of the different modules. So I just brought this up in a really quick Word document here. So the first topic that we covered in COSC 33530 was our multi-process programming topic, where we spun off processes in the Linux environment using the fork system call, and we managed them using the wait system calls. And we saw different structures like our fans and our chains and our trees that we could create these processes in. So you'll have to understand the basic system calls. There's always some questions about the fork and wait and all of the variants of those. And so you'd be expected to recall the input parameters, understand their functionality and the outputs from them. You'll have to program up either a fan, a chain, or a tree, or all of them. And you might even need to know the exec system calls to execute some common system commands there. So make sure that you cover that. That's all in the first couple of slideshows in that module. And then you'll also need to understand some of your process communication primitives. So remember in the course that the main one we concentrated on was connecting processes with pipes using the pipe system call. You'll need to know how to do this. You'll need to know the steps in the process, and you'll have to be able to code that up. But remember, we had some other inter-process communication primitives such as mapped memory, and we looked at file locking, and we also looked at FIFOs. So have a look at those as well, but there might be less of an emphasis on those ones. Then we moved on to the second module in the course, which is our multi-threaded programming. So in that one, we have a single process that has multiple threads of execution running within there. And remember that we were using pthread create and pthread join to spin those threads out. They have an entry point function. They execute the code in the entry point function, and then we wait for them to join using our pthread join function. So you'll need to know how to code up a multi-threaded solution, so with our thread entry point functions, and you'll need to know how to use pthread create and pthread join to manage them. So go through, that's all in the introductory content of that module. There'll be a mutual exclusion problem similar to that we covered in assignment 2. So recall in assignment 2 we had to implement a locking mechanism to simulate access to a bridge. You'll need to implement something similar to that in your exam. So make sure you cover your mutual exclusion devices, so your mutex calls, your conditional waiting and signaling, so that you can code that up, so you can code that question up. There'll also be a question covering one of the other 3 problems we looked at in that module, which were matrix multiplication, the classic dining philosophers problem, and the producers consumers problem. So you have to understand the problems and how to code up the solutions to them. So there'll be something on those problems. And the final, the MPI module, again, you have to understand the basic function. So there'll be some questions on some of them where you have to have the input parameters, the functionality, and the outputs. Remember that some of the MPI functions are a little bit peculiar in that they behave differently on the master and the slave processes. So remember that most of them have an input where you specify which process is going to be the master, and they do different things. So recall that scatter and gather are a couple of examples. On the master and the slave, they behave differently. Understand the tree and butterfly communication structures. We covered those in one of the final slideshows for the message passing interface. So they're implemented underneath all the scatter and gather functions, and we went through an explicit implementation in code using just the send and receive primitives. So you've seen that built out. So make sure you understand that structure and how it communicates data among the processes. And there'll be something from one of the case studies we did in the MPI topic. So we covered off on the integration example, and we covered off on the matrix multiplication example. So recall we looked at Fox's algorithm, which is a big concurrent matrix multiplication algorithm where we pass around rows and columns of data. So there'll be a question on one of those, so you'll have to understand how we implemented those. And our final topic, which is our NVIDIA CUDA topic, you'll need to know the basic functions, so CUDA mem copy, for example, CUDA malloc, all of those sorts of things, their input parameter functionality and outputs. and understand the CUDA memory hierarchy. So you've got your global memory, your shared memory, texture memory, and local memory, etc. So understand where they're used and the characteristics of each one of them, and pitched memory. So recall we looked at creating two-dimensional structures efficiently, and efficiently representing them. Creating two-dimensional structures that are actually implemented using one-dimensional arrays, and how we can use the pitched memory functionality in CUDA to do that. So understand that. There are a few other little bits and pieces in there, but these are the main focus areas. So the exam consists of 4 questions, and each of those questions is multi-part. The questions range from 20 to 30 marks each, so it adds up to a total of 100. And so that means that the marks are relatively evenly distributed through the content. So you have to sort of study which you should be studying each module with roughly the same level of focus. So the location of the past exams, this for the subjects have changed this year. They actually sit in a Moodle page. So I've linked that through. There's an exam preparation and hints post that will contain this video. I've dropped a link into that one. You'll have to self-enroll into it. There'll be a little enrollment button popped up. I've already done that to check the functionality out. If you jump into the comp section and jump down to Comp 309. So you can see here that there's three past exams for Comp 309, and there's also some for 509 as well. Go through those because the Comp 509 is the older version of this course, and it's very similar to what we cover, except for the topic on parallel virtual machine. We no longer cover that technology because we cover CUDA. So have a look at those past exams. There aren't any past exams for COSC 330, 530 available yet because we haven't built up enough questions to completely roll them around, so they'll be released in later years. But go through those past exams and use them as a guide for your studies. If you have any questions, please let me know. Feel free to discuss the past exam questions on the discussion board, and you can bounce answers off each other, and I'll come in and comment on them if you want me to. And essentially, basically, if you concentrate on sort of these topics, you'll have the core of the exam content covered, but make sure you go through as much of the course as possible. So in a typical question, I'll ask you to explain the concept using code snippets, or you'll have to do a program end to end. There'll only be a couple of end-to-end programs because I don't want you to waste time coding up main functions. So just read the questions carefully to make sure that if you're asked to do a full program, that you include the main function, all of your thread entry points or process entry points, etc., MPI functions. So you've got to have sections of code that both execute. That both the master and slave execute, so make sure you have all of those in there if you're asked to do a complete program. And same with CUDA, make sure you have your CUDA global kernel functions as well. So ensure that you include them if you're asked to do a full program. If you're asked to do code snippets, I'm after the relevant snippets of code that show the particular functions or the particular pieces of technology that we're concerned with in the problem. So that's all I've got for your exam revision post. If you have any questions, please let me know. Otherwise, good luck with your final exams.